Hello future polymer pros, I'm Bill Nye and today we're exploring the world of polymers, materials you use every day, often without realizing it. Polymers are the backbone of plastics, rubbers and countless modern materials. As inspectors, understanding polymers is essential for ensuring safety and quality in everything from water pipes to car parts. So, what's a polymer? Imagine linking paper clips into a long chain that's a polymer. Many small molecules, monomers, joined together. Polymers can be natural like rubber from trees or cellulose in plants, or synthetic like PVC and nylon. Knowing whether a polymer is natural or synthetic helps you predict how it will perform and what defects to look for. For example, natural rubber ages differently than synthetic silicone, even if they look similar. This course will give you the foundation to identify, inspect, and understand the story behind every polymer part you encounter. Let's get started. Now let's see how polymers are built and why their structure matters. Linear polymers are like spaghetti, long, flexible chains that can be melted and reshaped, as in polyethylene bags. Branched polymers have side chains, making them less dense and more flexible, like low-density polyethylene. Cross-linked polymers are chemically bonded into a tough, three-dimensional network. Think car tires or epoxy glue. Once set, they can't be melted and reshaped. Inspectors need to recognize these structures to anticipate material behavior. Polymers are made by two main methods: addition polymerization, monomers link up rapidly, as in PVC and polyethylene, and condensation polymerization, monomers join and release a small molecule like water, as in nylon and polyester. The synthesis method can hint at possible defects. Condensation can leave behind moisture, causing voids. Understanding structure and synthesis helps you spot weaknesses and ensure quality. Whether it's flexibility, strength, or heat resistance, it all comes down to how those chains are built. As an inspector, this knowledge is your first tool. Let's move on to the two main polymer families. Inspectors must distinguish between thermoplastics and thermosets. Thermoplastics are like chocolate, meltable, moldable, and recyclable. Their chains are held by weak forces, so they can be reshaped. Think milk jugs, pipes, and car bumpers. Common defects in thermoplastics include weld lines and sink marks from uneven cooling. Thermosets are like cake. Once set, they can't be remelted. Their cross-linked structure makes them strong and heat-resistant, used in adhesives, brake pads, and silicone gaskets. Thermosets can't be recycled by melting, and defects include incomplete curing or trapped bubbles. As an inspector, you'll look for different issues depending on the polymer family. Thermoplastics check for weak spots and shrinkage. Thermosets check for curing problems and voids. Knowing the difference is key to accurate inspection. Let's stretch into the world of rubber. Rubbers, or elastomers, are polymers with remarkable elasticity. They stretch and snap back thanks to coiled, lightly cross-linked chains. Natural rubber is tough and abrasion-resistant, great for tires. Synthetic rubbers like nitrile resist oil, while silicone handles extreme temperatures. Identifying the rubber type tells you what properties to expect. Key tests include hardness using a durometer, tensile strength, and elongation. Inspect for ozone cracks, chemical swelling, and compression set where a seal loses its shape and leaks. Look for fine cracks, blisters, or areas that don't spring back. Early detection of these defects prevents major failures. As an inspector, your job is to spot these warning signs before they become problems. Now let's reinforce our knowledge with composites. Fiber-reinforced polymers, FRPs, combine polymers with strong fibers for supercharged performance. The polymer matrix holds everything together. The fibers, like glass, carbon, or Kevlar, provide strength and stiffness. Fiberglass, glass fiber in a polymer matrix, is common in boats, pipes, and wind turbine blades. Manufacturing methods, hand layup, filament winding, resin transfer molding, affect the final properties and potential defects. Inspectors must check fiber orientation for strength. Look for voids or dry spots and ensure the right resin-to-fiber ratio. Delamination, layers separating, and surface wrinkles are common defects. Some issues are visible, but others require deeper inspection. Knowing how FRPs are made helps you know what to look for. Next, let's talk about advanced inspection techniques. Inspectors use non-destructive testing, NDT, to find hidden flaws without damaging parts. Ultrasonic testing sends sound waves into materials. Echoes reveal voids or delaminations. Thermography uses infrared cameras to spot subsurface defects by detecting temperature differences. Your job is to verify quality against standards, check documentation, use calibrated tools, and know industry specs. For example, inspecting polyamide conduits means checking heat resistance, dimensions, and surface quality. For PVC sheeting, look for thickness, color, and absence of pinholes or gels. Accreditation means mastering documentation, inspection tools, and standards like ASTM or ISO. Polymers are everywhere. Lightweight, durable, and essential to modern life. As inspectors, you ensure these materials perform safely and reliably. Your diligence keeps our world running. Thank you.